Problematics of the issues concerning development of energy-saving and environmentally efficient technologies of well construction. Any logically complete and integral geotechnological process of the development of mineral deposits is impossible without a wide range of integrated applications of such a special class of mine workings as boreholes. The purpose of the latter is to obtain the most necessary basic and a whole range of additional information about the physical, geological, and operational technological characteristics of the mineral deposit at all stages of exploration, development, and closure of the field. Analysis of the financial and time balance for the development of deposits convincingly proves its tight connection with the need for drilling operations and the existence of significant potential to reduce these costs. In this context, among other things, rationalization of the parameters of hydraulic program for well washing with the simultaneous optimization of fluid composition and sequence of tripping processes can be considered as the main reserves to overcome the outlined problems. Specialists of Dnipro University of Technology occupy leading positions among the researchers studying the features of implementation and operation of rational and energy-efficient schemes for the organization of circulating processes in drilling and operation of wells. In particular, they conducted in-depth and comprehensive research to study the physico-chemical phenomena used in the creation, preparation, and use of washing fluids, and their impact on individual processes and the entire cycle of drilling, especially its environmental component. Methodical hydraulic calculation of the circulation process is performed in order to determine the required characteristics of a drilling pump compressor, as well as a reasonable selection of its type, being the most appropriate to the calculated values and the required number of pumps. In terms of any drilling method, a size of slurry particles is characterized by a wide range, from a few microns to centimeters. To assess the possibility of transporting slurry by the flow of a cleaning agent, an average size of particles is usually taken, which together with the smallest fractions make up the bulk of the slurry formed. In this case, the individual particles at the bottom may be larger than the average size by 3 to 5 times. The average particle size of slurry depends primarily on the design of a rock-breaking tool. The particle size is larger when drilling in fractured and granular rocks, in terms of impact action of the tool and while drilling with a large axial load and low speed. Slide 2 shows analytical and practical data on the particle size distribution of fracturing products obtained as a result of research conducted at the Department of Oil and Gas Engineering and Drilling, Dnipro University of Technology, and industrial enterprises of the relevant profile. A value of the particle transport rate is selected according to the drilling conditions and should be sufficient to prevent slurry accumulation in a well. It should be greater than the drilling speed and well depth. For the most typical conditions of well drilling, a value of the minimum transportation speed for slurry particles is usually within the range of 0.02 to 0.2 meters per second. Analysis of the recommendations, taking into account the characteristic dimensions of the annular space for wells, demonstrates that the selection of the minimum flow rate of washing fluid should be made in terms of well diameter being up to 100 mm, at a specific flow rate of 1 cm of the rock-breaking tool diameter. In case of well diameters for more than 100 mm, at the required rate of upward flow. Field studies of the well bore cleaning process were conducted at a special drilling rig located at the territory of the training drilling site of the Department of Oil and Gas Engineering and Drilling, Dnipro University of Technology. The stand includes drill plunger pump, loss meter, well model, drill collar, drill pipes, suction and injection pipelines, drill rig, tank for cleaning agent sampling, ditch system, and collector. When drilling with blow-in to select the rational airflow, the same factors are taken into account as while well washing. The optimal value of airflow is determined by the condition of bottom hole cleaning and depends on the type of rock-breaking tool, composition of drilled rocks, and presence of water in the well. This value is determined experimentally. The choice of airflow only at the rate of upward flow with small values of the cross-sectional area results in the underestimated results. Approximate values of specific airflow per 1 cm in diameter of a rock-breaking tool are shown on slide 5. Drilling of wells in sedimentary rocks is accompanied by various complications, the most common of which is sticking, unforeseen accidents in the well, characterized by partial or complete shutdown of drilling tools, metal casing, or geophysical hydrogeological equipment and devices. Sticking is the most difficult and time-consuming drilling accidents. There are three main types of sticking: of drill strings, of casing, and of rock-breaking tools and rotatable drill pipes. Slide 6 provides specific guidelines for selecting efficient washing systems for the construction of wells in soft sedimentary strata. If there are clay rocks in the well section, first of all, the ability to swell determines the degree of complexity of the wellbore constructing process. Clays containing mantumolonite are called bentonite. When swollen, they can increase in volume by up to 14 times. Current drilling practice proves that it is the use of clay-based drilling fluids that in most cases can prevent possible complications in the wellbore associated with the manifestation of various physicochemical properties of sedimentary rocks, in particular in clay. However, the effectiveness of the application of clay-based solutions can be maximum only under conditions of special processing of drilling mud, which involves physical and chemical treatment of the dispersion medium. When preparing clay-based solutions, it is necessary to control the following main technological parameters. Based on the in-depth study of literature sources as well as thorough analysis of industry and laboratory data, the most important factors in improving the drilling quality were outlined and the main areas of comprehensive improvement of well technology were identified, in particular in terms of designing a rational hydraulic well washing program. Thank you for your attention.